Okay, so now we'd like to figure out what the sum is for these things. And the surprising fact is that there's a beautiful little trick for figuring out a formula for these partial sums. So here I've written out SK. This is the partial sum of our geometric series where we start at n equals 0 and go up to n equals k. And then what I'm going to do is I'm going to take this thing and I'm going to multiply it by r. And so we have r times sk. And I'm just going to take this, and this is just pure algebra right here. Right? This is going to be, I'm going to pull out I'm going to line it up directly under that so it's obvious what's going on. I'm going to get r plus r squared plus r cubed plus etc. all the way up to r to the k plus 1. And let me close my bracket. Okay, so that's just r times sk, right? So I took this formula I had up here for sk, and I multiplied it through by r, and this is just a pure algebra manipulation. But now the trick is that I'm going to take the difference between the two of them. I am going to calculate sk minus r times sk. And here, that's where the magic comes in. Right? These terms are going to pair up with each other. These terms are going to pair up because here I have r and r. So when I subtract, these two are going to kill each other. And here I have an r squared, and there I have an r squared. And these terms are going to kill each other. And so on and so forth. And then this rk here is going to get killed with, well, with the guy who's like right there. Right, there's an rk right there, and this r cubed is going to kill somebody in my dots. Right, so these terms are going to match up, and we're going to have two odd people out. Right, this one here has no partner down below, and rk plus 1 has no partner up at the top. So when I take sk minus r times sk, well, my c factors out in front, and then I get that 1, and then I get minus r k plus 1. And I'm going to go ahead and circle these in red because I had them in red on the previous line. Okay, so now we have a really simple expression on the right-hand side, and the left-hand side is something we can solve for sk. Right, so that means that if I take 1 minus r, times right, I get 1 minus r here times sk, that's equal to c times 1 minus r to the k plus 1. And now I just isolate sk. So I get c times 1 minus r to the k plus 1 divided by 1 minus r. And that is a formula then for sk. Okay, I did something a little bit illegitimate here without making an assumption on r. So I'd like you to think about what it is that I did and what r value messes this up, and what you get in that case. Okay, so then the conclusion from this is that we have a formula for the partial sums of our geometric series. And then that allows us to conclude as to what the actual infinite series does. Right? So this infinite series is going to have a limit as k goes to infinity, if and only if this expression has a finite limit. Right? That's the series converges. The series converges if and only if this limit, that expression has a limit. Right, and that's precisely the question we need to resolve. And if we take a limit as r goes to infinity, if r is a negative number that is smaller than -1, this thing is just going to oscillate, and so there will be no limit. If r equals -1, this also oscillates and there's no limit. If r is less than 1 in absolute value, this whole power of r thing is going to 0. So then there is a limit, and it's precisely c over 1 minus r. And then if r is greater than 1, this thing blows up. Right? This goes to, if r is greater than 1, this whole circled expression, well, if c is positive, it goes to plus infinity, and if c is negative, it goes to minus infinity. So then if r is greater than 1, there's the limit is infinite. And finally, if r equals 1, this formula is invalid, but we also see directly that this the partial sums won't converge if r equals 1. So the upshot is that this series, this geometric series, converges if and only if the absolute value of the common ratio is less than 1. And in the case that it converges, the series takes the value c over 1 minus r. And now this fact here is something that I encourage you to memorize and know, because this is a very important fact, and this right here is going to be very useful, and well, basically everything on this slide is going to be incredibly useful down the road. So do be sure to know it.